Now let's take a look at trigonometric substitution, case 2. This will be the case where we have a squared minus x squared. In this case, I'd like to integrate 1 over the square root of 9 minus x squared. Again, we have no other technique available to us, and so this is our only option. So the first thing we're going to do is we're going to change the integral, again using the correct trigonometric substitution. In this case, the integral contains a squared minus x squared. And again, if you can't see that, remember 9 is 3 squared, so we actually have 3 squared minus x squared. So our a is 3. So we're going to use x equals a sine theta. So if I do that, x would then be 3 sine theta, and when I take the derivative, I get 3 cosine theta d theta. Now I do the substitution. Again, in for x, I put 3 sine theta, and then in for dx, I put 3 cos theta d theta, which is what I did here. Second step, simplify the resulting substitution. So what I'm going to first do is square what's under the radical, the 3 sine theta. When I do that, that gives me 9 sine squared theta. So there I was squaring out this portion. Now, like I did in the prior example, I'm going to factor out a 9. And when I factor out a 9, that leaves me with 1 minus sine squared theta. Some of you are probably going, oh, I know what 1 minus sine squared theta is. Well, we'll get there. Now what I'm going to do is take the square root of 9 and the square root of 1 minus sine squared theta, and the square root of 9 is 3. And then remember, we can't just take the square root of 1 minus sine squared theta. We're going to have to rewrite it first. Now before I do the rewrite, I noticed I had a 3 and a 3, so I canceled those. Now, hopefully you remember that sine squared theta plus cosine squared theta equals 1. Or in other words, 1 minus sine squared theta equals cosine squared theta. So I'm going to take out my 1 minus sine squared theta, and in its place I'm going to put cos squared theta. Follow my nose to the simplification. Square root of cosine squared theta will give me cosine. So I have 1 over cosine theta multiplied by cosine theta d theta. And I'm sure at this point you feel pretty good about canceling the cosine thetas, which just leaves us the 1s. Now I'm going to integrate the resulting trigonometric integral. Now be careful here. Many of you are probably saying, oh, I know the antiderivative of 1, it's 1x. Well, I don't have an x this time, I have thetas. So the antiderivative of 1 d theta is theta. So my antiderivative will be theta plus c. Now, step 4, now that I finished my integration, I need to use my substitution and SOHCAHTOA to draw a right triangle. Quite frankly, in this example, we don't really need the right triangle. Because we have a theta, we don't need another trig function. So I'm going to actually not use it at this point, because I don't need sine, cosine, tangent. I don't need a trig function. What I am going to do, though, is I am going to take my substitution and solve it for the trig function I used. So sine theta is x over 3. And now I'm going to solve this for theta. You might say, how? I don't remember how we do that. Well, remember, to solve something for theta, you can take the inverse sine of both sides. So the inverse sine of sine theta and the inverse sine of x over 3. Since inverse sine or arc sine and the sine function are in fact inverses, we think of them as canceling each other out. And when they cancel each other out, that's what we get. So theta is inverse sine of x over 3. Then we're going to use that to convert the integral result back to x's. Now remember, our integral result was theta plus c. So I just put this in for theta. And I have inverse sine x over 3 plus c. If you prefer, you can write arc sine x over 3 plus c. For a lot of people, that's a little bit neater and a little friendlier.